Let's be real for a second. The Android system design interview can be super intimidating, right? You get this vague question, you're staring at a blank whiteboard, and it just feels like there are no right answers. It's so frustrating, especially since there are hardly any good resources online to help you prep. Well, today, we're going to change that.
All right, let's jump right in. Here's our game plan. First, we'll figure out what this interview is really all about. Then, we'll quickly go over the toolkit you already have. After that, I'm going to give you a 4-step blueprint that works for any question. We'll use it on a real-world example, and then top it all off by learning how to think like a staff-level engineer. By the end of this, you'll have a solid framework to walk into that interview with confidence.
Okay, first things first, let's really get our heads around the challenge. This is not your standard coding interview where you're just grinding out an algorithm. No, this is a whole different beast.
So what is it that makes it so different? Well, it's pretty simple, actually. It has almost nothing to do with your ability to write code. You're not being judged on whether you can write perfect Kotlin syntax while someone's watching you.
This right here, this is the whole game. Companies want to see how you plan, how you design apps that can scale, that are efficient, and that won't be a nightmare to maintain. They're not just hiring a coder, they're hiring an architect, a strategist.
So the most important thing you can do is shift your mindset. Stop focusing on the tiny details, the individual lines of code. It's about zooming out and seeing that big architectural picture. You've got to think about how all the pieces of the puzzle, the UI, the database, the network calls, all fit together to create one solid working system.
And here's the good news. You already have all the tools you need for this. Seriously, you're not starting from zero. So let's just do a quick refresher on our toolkit to build up that confidence.
Okay, so at the very, very bottom of everything is the Linux kernel. You can think of this as the foundation of the entire building. It's the heart of the OS, handling all the low-level stuff like drivers, memory, and making sure processes play nice with each other. It's that critical layer between the physical hardware and all the software running on top.
Now, sitting on top of the OS, we have our application's architecture. Patterns like MVC, MVP, and MVVM, these are basically your playbooks for how you organize your code. They make it way more maintainable, easier to scale, and a whole lot easier to test.
Now, what's really cool to see here is the difference in how these patterns handle relationships. With MVP, you have a really tight one-to-one link between a presenter and a view. But with MVVM, you get a ton of flexibility because one single view model can actually serve multiple views. And the really important part, it does this without holding a direct reference to them, which is a huge help in preventing memory leaks and just works way better with modern Android tools.
And of course, we've got solid. These are like the golden rules of writing good software. You've got S for a single responsibility. Every class has one job and one job only. O for open-closed. You can add new stuff but not change existing stuff. L for Liskov substitution. Basically, child classes should be able to stand in for parent classes without breaking anything. I is for interface segregation. Don't make classes implement methods they don't need. And finally, D for dependency inversion. Depend on abstractions, not on concrete details. Getting these down helps you build code that's truly rock solid.
Okay, so we've got our tools, we've got our design rules. Now let's build the blueprint. This is a clear, step-by-step framework that you can use to tackle any system design question they throw at you. This 4-step plan is your key to giving a structured, impressive answer. But listen, the most important step here, the one you absolutely cannot skip, is the first one. Don't just jump in and start designing. You have to ask questions first to make sure you deeply understand the problem. So, for step 2, you break things down. Think of functional requirements as your feature list, the what the app needs to do. For a chat app, that's sending messages. Non-functional is all about the quality, the how well it should do it, like being fast, secure, and working even when your internet connection is flaky.
And in step 4, you got to think about how the app is going to talk to the server. For things that only happen once in a while, like fetching a user profile, a standard HTTP request is fine. It's like sending a letter. But for a chat app, you need that instant back-and-forth communication. That's where WebSockets are perfect. They keep an open line, like a phone call, for all that real-time stuff.
Okay, so a framework is only useful if we actually use it, right? Let's get our hands dirty with a practical example and see how this blueprint works in a real interview.
So imagine this. You're in the interview, and the interviewer hits you with this classic question. It's intentionally broad and open-ended because they want to see how you think. Where do you even begin?
You start with your blueprint. Simple as that. First, you clarify requirements. You start asking questions like, does this app need to work offline? Or are we talking push notifications for breaking news? Once you get those answers, you can define your scope and then start identifying the key components you'll need. A really solid design will have a layered architecture like this. You've got your UI, your view model managing the state, and your API layer talking to the outside world. But the real hero here is the repository. It's like a smart traffic cop for your data. It decides, hey, should I grab this data from the local room database to show something on screen instantly? Or do I need to go out to the network and get the freshest news?
Now, just listing off a bunch of components is good, but it's not great. To really nail this, especially for senior roles, you need to show your thinking on a whole other level.
And this is what separates a good answer from a truly great one. It's showing you can make smart trade-offs. You have to balance what's technically perfect with what the business actually needs. Do we need military-grade encryption for our local data? Can we use a third-party tool to ship this feature faster? These are the real-world decisions that senior engineers make every single day.
At the end of the day, they want to know if you can be a true partner in building the product, not just a coder who takes tickets and closes them. It's all about seeing the big picture, being able to explain complex ideas simply, and using your technical knowledge to help steer the product in the right direction.
And really, it all comes down to this final question. The ability to answer this, to know when to consciously trade a little quality to gain speed, how to contain the risk of doing that, and then making a plan to fix it later, that is the true hallmark of a senior engineer. That's what's going to make you stand out. That's what's going to land you the job.